All right then, welcome back everyone. So in this video, we are going to solve this interesting question, set matrix zeros. Now this is a very important question when coming to coding rounds. I mean, it's a famous question. It is asked by many companies like Amazon, Uber, Adobe, Microsoft. And this was asked in recent time, this is I'm saying in past 6 months or so, this companies asked this question. Okay, so this shows how important this question is. So anyway, the question is very simple. The description is very simple. So basically, you'll be given a matrix, and some of the entries in this matrix will be zeros. So what they're saying is, if an element is zero, set its entire row and column to be zero. So if you found a zero here, you have to turn its entire column and entire row to be zero. Simple, right? So let's think how are you gonna let's build up the solution. That's what I'm saying. Let's build up the solution from brute force to the most optimal one. All right. So what is the most brute way of thinking this solution? What is the most brute way? The most brute way is like you go through every zeros. You go through every zeros, and whenever you find out a zero, you turn its entire row and column to be zero. That's the most brute way, right? So basically, of course, I cannot change it into original matrix because let's say if I go to the zero, I'll change this zero, I'll make this zero, I'll make this zero. So when I go here again, this will be seen as zero. Then it will again do the same. So of course, you'll need a new matrix here. So I'll need a new matrix. So this shows you'll need some extra space here. That's also one thing. You'll need extra space here. And what you can do is you can just traverse this matrix, our original matrix is our original matrix. And whenever a zero is encountered, we can set its corresponding row and column, the new matrix to be zero. This is simply achieved. Uh, let's just see how it. What I was saying is, I'm just going to create a copy of this matrix. I'm going to just create a copy of this matrix, and I'm going to make changes in that new matrix. Okay, because I don't want to mess up with the elements of this matrix. Fine. And whenever zero is encountered, we're going to set its corresponding row and column, the new matrix to be zero. It's very simple. So what the set zero does is, it takes a row, takes a column, and sets the entire row and column to be zero. Fine. Okay, so the set matrix zeros. Okay, so I've created a new matrix here. I'm going to create a new matrix. These are just initializing it. N and M, n is number of rows, n is number of columns. And I'm going to go through every element in my original matrix. And whenever I found out a zero, I'm going to use this set zero function to set the ith row and jth column to be zero. And that code is pretty straightforward. Okay, that's not much here. All right, so that's the brute force approach. What is the complexity analysis, if you will? Uh, so the complexity analysis, like space complexity, is of course M into N because we are using a new matrix. That's obvious. And what is the time complexity analysis? See, what you're doing is you're going through every entry. Like in worst case, what can happen is uh, everything can be zero. Now you're not checking here that if you are randomly just whenever zero is found, you are making the entire row column to be zero. So what you're doing is you're doing m plus n work. You're doing m plus n work for every entry, right? In worst case, you might have to do it for every entry. You'll have to do m plus n work. So there's a time complexity m into n for every entries. This is my number of entries. Okay. Very bad handwriting here, but anyway, you got the point. And m plus n, the work you have to do, right? Yeah, good. So that's that. Now we can optimize this. We can optimize this. Now, how are you going to optimize this? Let's see. So, and then what you need to do is like whenever a zero is encountered, whenever a zero is encountered, what you need actually, whenever zero is encountered, you just need to say, okay, if this zero is encountered, mark this first row. I'm just using zero as indexing. Mark the first row and the first column that it should be turned into zero. So that's exactly what I'm going to do. I have here basically n rows, right? I have n rows and m columns. Okay. So what I can do is I can create like a flags for all the rows and columns. Okay. So I'll have like a marker array, like a flag array for the rows, and I'll have a flag array for the columns. Okay. Uh, yeah. So what I'm gonna do is whenever a zero is encountered, I'm gonna mark. Okay, this row needs to be turned into zero. That's exactly what I'm gonna do. See, we are able to the space if we just mark the corresponding row and column that needs to be turned into zero. That's exactly what we are gonna do. So basically, we need to maintain two flag arrays, row flag and column flag. And of course, sizes are like it should equal number of rows and number of columns. Fine. So yeah, and how I'm defining the state. If state is -1, this row need not be touched. But if the state is zero, then it needs to turn to zero. I mean, you can keep any state. Right? It will be like a binary thing, right? One state will represent, keep it as it is, and zero means turn it to zero. Fine. So we'll have to do two traversals, right? I'll have to traverse the matrix once, and I have to like update my flags, right? I'll have to update my flags. That you can do very easily. And now using our flag arrays, we can make the required cells of this matrix to be zero. So right. So what I'm saying is, so here's my matrix, right? So there will be two flags, row flag and column flag. Okay. So okay, three entries, -1, -1, -1, -1, -1, -1. So after I'll travel, I'll basically start from here. I'll traverse this. Okay, zero is found. So mark the first column and the first row. That's exactly what I'm gonna do. Mark it. So I'm gonna mark it. Okay, this needs to be turned into zero. Okay, and similarly, I'll go to every other entry, and I won't be able to mark any other row at all. All right, then basically traverse the matrix again. I'm gonna check, is a row or column marked? 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 That's what I'm gonna do. So when I'm here, is your row column marked? No, so I'll not make it 0. I'm gonna see, is your row column marked? Yeah, it will see. Okay, my column is marked. Column? Yeah, my column is marked. So I'll turn it into 0. Similarly, right? Fine. So that's what I have done here. See. So these are just like I'm taking out finding out number of rows and columns. These are my flag arrays. For row flag, it is equal to number of rows. Column flag, it is equal to number of columns. Okay, I'm going through a matrix and I'm setting the corresponding. Basically, for matrix ij, I'm setting the ith row and jth columns flag to be 0. I'm making it okay. Mark this. I'm marking it. Right now, of course, one more traverse to change the matrix. So I'm going through all the entries and see if either for basically for a value matrix ij, if either row flag, if this row was marked or this column, is this jth column marked or this ith row marked, I'm gonna make it 0. Simple. So there are simply two traversals here. So time complexity is simply big of m into n. It's 2 into n, but you can write asymptotically it's big of m into n. But we are using extra space, right? M plus n. This m plus n space is it at this extra space. Now, can we improve it further? Like time wise, I don't think we can improve it. We have to traverse entire matrix, but space wise, can we get rid of this guys? This is an important question. So let's think what you're doing. We are maintaining flag arrays, right? We are maintaining flag arrays. Okay, we are maintaining flag arrays for rows and columns, right? Maintaining flag arrays for rows and columns. Okay, so what can you do? Like, I want like a flag array for a row and a column. This is a tricky one, but try to understand it. What you can do is like, I need this, right? So why not I just use this first column itself as my row flag, right? I can do it, right? Because why not? I can do it. Why not I just use the first uh, row as my column flag, right? So whenever a 0 is encountered, I can just mark this guy to be 0. Because anyway, it has to be turned into 0 in the end, right? So whenever, let's say, 0 is encountered here, let's say there was a 0 here, I'm going to mark this guy 0. And it doesn't hurt. Why doesn't it hurt? It doesn't hurt because anyway, it was going to be turned into 0, right? So what I'm saying is, whenever a 0 is encountered, you just mark the corresponding first row or first column to be 0. Okay, I don't think you understand it. So what I'm saying is, so if you let's say a 0 is encountered here, what does it say? It says that the second column and the first row, second column and the first row needs to be turned into 0. So anyway, what I'm saying is these entry has to be turned into 0 and these entry has to be turned into 0. So why not I use them as flags? Why not use them as flags? Right? So that's how you think. Okay, yeah, I can do that. There's only one catch here. The catch I guess you can figure out. Look at this cell. This cell is actually part of the row flag and column flag both. Now that cannot happen, right? This is a binary, like we are presenting binary information there. Either 0 or not 0. Okay, either 0 or non-zero, basically 1. So it can only represent like two states. We cannot represent. We want this cell to represent four states. What are four states? Uh, Two states are like whether this row should be marked 0 or not. Okay, two states here and two states whether this column needs to be marked 0 or not. So how can we do it? It's simple, right? You can just include it at any one of them, and I can just maintain a separate variable. So what I'm saying is exactly, I guess I've explained put the image here. Yeah. So that's what I'm saying. So you can include in any part, either row flag or column flag doesn't really matter. Uh, and I can just maintain a separate variable. Simple, right? So you can do it either way, okay? But fine. Here's what I'm gonna do. I'm gonna treat the first column as my row flag. Okay, so whenever let's say 0 is encountered here, I'm gonna mark this to be 0. Okay. And when a 0 is encountered here, I'm gonna mark this to be 0. Okay. If a 0 is encountered for the first row itself, somewhere here, I'm going to mark this. If 0 is encountered here in the first column, I'm going to mark this variable. Okay. Simple. Very simple. All right. So, yeah, that's what I've written, I guess. If you want to get rid of space, we can use 0, 0, 0 columns flag arrays. And yeah, matrix 0, 0, the basically 0, 0 cell can represent two states, right? 0 and non-zero. So it can be either part of row flag or column flag. Okay. So if I'm making it part of a row flag, it will require one more variable to have the marking of 0 column. Fine. Cool. So what is the approach then? Approach is simple. We have to make a traverse with the matrix and we have to mark these guys, right? As I told just, okay, I have to mark them. And what you have to do is then do one more traversal and first change these values. It's obvious, right? Why I should change these values? Because it might happen like if there is a 0 here, it will make all of them 0. So that you don't want to do, right? So basically first change these values, right? Why not? Why touch our flag arrays? Okay. So step number one, step number one, actually mark. Okay, mark. You have to do mark. In step number two, you have to traverse from 1, 1 till I guess there are n, m. So I mean, of course, this will be minus 1, minus 1, but you got the point, right? You have to traverse this portion. Okay, that's step number two. And step number three. Now you have done this. Now you want to actually figure out whether this first row will be turned into 0 and whether this first column will turn into 0. Now here comes a very important part. Okay, hear me out very with your utmost attention. So which one are you going to update first? Are you gonna first check, okay, column flag and make this update, or are you gonna check this and make this update? Now, I guess I already showed you. If you think about it, it's obvious that if I check this column flag and update this zeroth row, sorry, zeroth column. If I check this column flag and update the zeroth column, what can happen is, if this guy wasn't zero, it can be turned into zero, and it can give falsely signify that this row also has to turn into zero. Okay, I guess you don't understand it. So what I'm saying is, let's say this was one. Okay, let's say this was one. So what is this saying is, this row has should not be turned into zero. But let's say this column flag was zero because this is independent, right? This is an independent variable. We cannot like this doesn't depend on anything. Like if there was some zero here, if there was some zero here, this will be marked. This column flag will be marked, right? This column flag will be marked. So I cannot first update this thing. I cannot first check if first column has to be turned into zero. Okay. So I'll check. Okay. So I'll first check whether this first row has to be turned into zero or not, because that doesn't change anything. So basically, I'm gonna first check if first row needs to be made into zero. Then I'm gonna check if first column needs to be turned into zero. Fine. Cool. So again, the steps are obvious. Let's just see. I'll just create the approach here. The steps are obvious. We are gonna first traverse the matrix. Okay. We are gonna traverse the matrix and mark the rows and columns which has to be turned into zero. Fine. Okay. I guess I've already showed you how that needs to be done. And then traverse the matrix from this portion, right? From 1, 1 to n, n, except the basically first and first column. Okay, that is the first and first column. Okay. And turn the cell zero, either one is row column is marked, that's obvious. And then how are you going to modify this first? I mean, I guess I have misused the term, but you got the point, right? This is what I'm saying, zeroth column and zeroth row. Okay. Important. Because this call flag can update this value, update this matrix 0, 0. I'm not gonna Yeah, I'm not gonna try to update the first column first. I'm gonna see if first row needs to be updated. That's what I'm gonna do. Okay, the reason is there's a chance matrix 0, 0 is seen from a non-zero value to zero by the independent variable. This basically this I'm just in column flag. Right? Okay, this will falsely signify the first row also needs to be turned into zero, which is not, right? If this guy was zero, it will falsely signify, okay, make this zero. Then when I come here, it will say, okay, okay, make this column also zero. But that need not be done, right? I guess I've made my point clear. So let's see the code, how we are gonna do. So this is just the extra marker for zeroth column. So this is how we're going to do marking. We're going to go through every entries. And if matrix ID is 0, I'm going to mark. So basically, I'm going to mark the ith row, right? So I'm going to mark it, right? Simple. So this is your entry. If you are ij, ith row is here, right? It's basically I comma 0, right? It's obvious. And then I'm going to mark this column. But I have to be careful. If the column is 0, if column is not equal to 0, yeah, I can simply mark it. So basically, if I'm here, I can simply mark this thing, right? I can simply mark this to be 0. But if I'm here, I have to mark this. Cool, very easy. Okay, if it is not equals to 0, simply update this marker or update this column. And see the matrix from 1, 1 to n minus 1, m minus 1. Okay, that's obvious. The remaining portion. And then, important, should I change the first column or first row? I have to change the I have to change the row first. Okay, I have to change the row first. Cool. So this is what I'm gonna do. I'm gonna check, okay, is matrix 0, 0 set to 0? If yes, I'm gonna set basically the zeroth row or first row basically to be 0. And the zeroth column is marked. I'm gonna turn the zeroth column to 0. Fine. The time complexity is simply mn. Okay, 2 into mn, but fine, it's mn only. That's based on the order. Fine. So yeah, that's that. So I hope you understand it. Now you can of course find the supplementary blog attached to it. It actually contains the same content. So if yeah, that will have everything. The codes and all will be in the blog itself. So I'm not gonna create any GitHub repo for it. So yeah, that's it from this video. I hope you got this question. I'll see you in the next video.